down. Okay, so those are all some simple derivatives that you can all do, and you just got 16 points. Right? So you already have
and now we're
16%.
approaching territory.
Okay, now we're into the word
I
problems.
didn't understand.
Okay. What are you going to do with this
Draw a
problem?
picture.
Draw a picture.
Guess what I'm
right?
gonna do.
So we have an intersection. They already wrote a story.
But I want to write
It
one.
says car A is traveling east away from an intersection at 20 miles an hour.
Never eats. You have a I do.
Car B is traveling north towards the same, oh, this is 20 miles per hour. Car B is traveling towards the same intersection at 15.
How do you know it's coming from
Okay, even they bolded it and everything. At what rate is the distance between the two cars changing when car A is 0.3 miles and car B is 0.4 miles from the intersection? So this is one of those really easy ones.
So is this one? Oh, that is pretty easy.
So give me a thing.
Well, it's
Pythagorean theorem.
0.3,
So x squared plus y squared equals z squared. What are we trying to find?
We were trying to find
We're trying to find the diagonal distance, how the rate that that's changing. So we're trying to find
Okay, can you pause?
ZDT. Yeah, I'm going to go now. Okay, so now we have to do what?
I love that.
Take the derivative. So it is going to be 2x dx dt. We've done this problem like 17 times.
This is actually easier.
2y dy dt equals 2z dz dt. Okay, so now we just have to plug some stuff in.
So 2
2 times what's x? 0.3 because that's the distance car A is from the intersection. The x dt is 20 plus 2 times
0.4 times
0.4 times 15 equals 2 times, now we have to figure out, okay?
Why wouldn't 0.4 be negative?
Good question, why wouldn't 0.4 be negative? Okay, but aren't we looking at like a coordinate system and this distance is below the x-axis? Okay, so it would be negative.
That's what I think.
Okay, well, what does it say in the answer?
But it's going toward the.
Right, so the rate of change is positive because it's going up, which is in the positive
Yeah, what
direction.
does the answer?
They say it's negative, right, because it's below the x-axis. So that's important that you guys keep that all. That's the kind of little tiny mistake that will make the whole thing wrong.
That was
That's what I
like.
would do.
Well, I just
Sure,
remember
because you're
you
gonna end
said
up
positive
adding this
about
instead
wrong.
of,
So you'd still get.
you probably get some points, yes. Unless your father or your teacher. I love looking at your, you got a card report for the quarter. I should frame those.
Why?
Because you have A's in all your classes except mine.
Seriously?
Yeah.
I do have A's in all my classes.
Well, you have A minus in,
Astronomy.
yeah. Okay, anyway, and then you also have to figure out what Z is, right?
Yeah.
0.5, because it's a 3, 4, 5 right triangle.
Austin said that, I was
And
just
then,
quoting it.
okay, so you're giving Austin credit where credit
No,
is
we were
due.
pretty excited. You say that was
Right, because it's 0.3, 0.4, so that's going to be 0.5.
Oh.
Okay, and that one will always be positive.
I do.
Okay, and then you just have to solve, right? And then you just have to solve, right?
Aw, that was nice of Austin.
Austin's always
We should
right.
mark this on the calendar.
So let's do, what's 2 times 0.3 times 20?
A negative or
12.
12. Okay, then this is going to be minus 2 times negative 0.4 times 15 is,
12.
it is?
Yeah. It's below 0.
The answer is 0.
Yeah.
And then 2 times 0.5 is 1, dz dt. Is that correct?
Yeah. That's stupid.
It is stupid. So the correct answer to that problem is 0.
Everything's 0.
Weird.
I hate this class.
You love this class and you know it.
The only reason I like this class is because Ruthie always has candy and people make cookies.
You know what I want?
If I had to make a graduation speech,
You
that
know
would
the
be
ones I
my
had to dream about. Yeah.
Okay.
That's what made me think of it.
Let's talk about part B.
I guess on this one.
Those
Okay.
are so stinking good.
Um,
Red velvet brownie.
Now, part B is, how do you want to do it? It says, is the distance immediately after that increasing or decreasing? Okay? Yeah, that's what I would suggest that you do. Okay? Is just to change these distances, yeah. So say, we know that this is 0.3, 0.4, and 0.5, okay? So let's change this 0.3 distance to be 0.2.
Wait, no. You could put that backwards.
I do?
It's 0.4.
Oh, okay, so let's change this to be 0.2. Well, let's make that 0.3, and then make, and I guess technically you'd have to say how much time would have passed to make, maybe that's a bad idea.
Yeah, I don't think.
Maybe a tangent line equation.
Yeah, you have to do that differently, okay. So, what else do you want to do then? You guessed and you got it right? Because, I mean, isn't it obvious this guy's going faster away than that one's going towards it? So this one's going to get smaller and that one's going to get bigger and the distance is going to increase.
Yeah.
They found the tangent line equation.
Yeah, they did a lot of
I
crazy
took a rubber
Oh,
band,
wait, no, they didn't.
stretched it like this and held it here, and then go like this and pull,
Uh-huh.
and this was too long.
They took
That's
the
smart.
They did the second derivative test to see whether it was concave up or concave down, but I'm thinking we don't need to go there. Seems like a lot of work. Okay, so far we're okay, right? And that's a great example of what I was talking about at the beginning of class. If you get to that problem right there and you don't know how to do that part, skip it. Make something up, and we're going to move on. It's only 2 points. Okay? Don't spend half an hour trying to figure out everything.
I like that idea. Make something up.
But don't spend more time in.
Right. Okay, use tangent line approximation to estimate the x value at a point of x, comma, 0.003 on the curve, da 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 da.
We have to take the derivative.
I think we could read.
Tangent line.
Okay, so what do we got going here?
Oh.
Take the derivative.
Take
I
the
took
derivative.
the arctan first.
You did?
I think it's gonna be easier because, like okay, this is kind of weird. What I did is I solved for y first,
Uh-huh.
but I know lots of people, other
So
people.
you solved for y and then took the derivative of that way? Okay, you can do that. Implicit differentiation isn't so bad. Okay, so we're just gonna go with implicit differentiation. Okay, so the derivative of x is 1. The derivative of tangent is
Secant squared.
secant squared. And we leave this stuff alone.
And then you multiply it.
And we multiply by the derivative of the stuff inside, which would be
4 minus 5.
4
This one actually
minus,
isn't.
So did you just take the derivative?
yeah,
I did that.
okay? dy dx or y prime, whatever, okay?
Wait.
Then you plug in 0.
And then you plug in 0 for x and 0 for y. Because it says near 0, 0, right? So if I plug in 0 for both of those, that's just going to be 0. Right? We messed with the secant of 0 a lot yesterday.
It's 0.
It is
Or no, it's 1.
1.
I have it crossed out.
So 1 equals, yeah, that equals 1. So 1 equals 4 minus dy dx.
So be my dx equals 3.
dy dx equals 3. So how does
What
that
do you
help
do
us?
after that?
Okay, that means that's the slope of our tangent line. It's 3. Okay? The point that our tangent line goes through is 0, 0. So the equation for our tangent line
Y
is
is 3x.
y minus 0 equals 3 times x minus 0, or y equals 3x.
I got the same.
But they want you to find
Okay,
the
yeah,
x.
your way, like I said, your way would work if you solve that for y and then go through there. Okay, so now we need to use that to figure out what x is when y is 0.003. So take and plug in 0.003 for y. Solve that for x.
I did something to you and you feel so bad. Yes, go fix it.
That's right.
And that's the answer. Okay?
You know what I wish?
World peace.
I wish there was a job where I could only teach elementary school math.
Yeah,
There it
your
is.
mom wishes you could just keep those.
Science.
Grade.
So maybe we should build our own.
I'll just school of
Yeah.
You can do that in bigger districts.
Yeah.
Some districts have like the math person and the science person.
But for elementary school.
Right, no, so you go, you go, you know, like Karen goes to different schools, and
Yeah.
like that, they sometimes have that same thing.
What if you did junior high? No. Well,
No,
elementary, no.
bigger.
I think elementary would be hard to teach junior high. because-
Yeah, but I've been teaching elementary school kids for
Little
3 years.
four eggs.
Okay, well, we just went through these yesterday,
Yeah, also that.
okay?
Like teaching them math.
We start out by trying to plug in 0, right?
Yep.
Well, what do you get? 0 over 0. So what's your solution to that problem?
L'Hopital.
L'Hopital. Okay. You plug in 0 here, you get 0 over 0.
So now all of a sudden I use L'Hopital for every single one in the world.
It's
I
using
feel like-
zero.
Only using L'Hopital.
I know, but that's been every
Work,
one.
right?
Okay,
If it's
let me write
0
this
over
down.
0 or infinity over infinity.
Isn't it the hospital is high violence? Okay. For
You're thinking of if we have some square roots in there, we're gonna rationalize it out. If you multiply by sine of x plus x, nothing's gonna cancel. But hopefully there will be a limit like that in here. Yeah, you're thinking of part D. Okay, so the derivative of sine is cosine. The derivative of x is 1, and the derivative of that is 3x squared. So
Okay.
these nasty college professors just figure these out to make our lives more difficult.
So wait,
I don't like doing
Yeah.
this over and over again. Negative.
that's, so you just take the derivative and then plug in infinity and
Plug in 0,
plug in 0.
right.
So,
So its limit is x approaches 0, so plug in 0.
so the hospital or whatever.
L'Hopital's rule.
L'Hopital's rule. Just take the
I got
derivative
that.
of the top and the bottom separately.
Right,
And then plug in
go
0.
around again.
Alright.
Yeah.
Until you get,
To the answer.
Negative cosine.
Okay, and so when we did this time, if I plug in 0 right here, the cosine of 0 is 1. 1 minus 1 is 0. This would also give me 0, so I'm stuck again.
okay, so then you do it again.
What if it's like approaching 3 but it still ends up 0 over 0?
Well, you can still do it. Yeah, I think you're okay with that. I'm not sure about that. I might need to look that up. Okay, so now I take the derivative again. The derivative of cosine is negative sine. And the derivative of 1 is 0. Take the derivative of the bottom and get 6x. What do you know? 0 over 0. Now I'm going to do it again. The derivative
Seems
of...
like you have to do this until you just figure it out.
Yeah, right. Derivative of negative sine of x is negative cosine of x. And then now, like you said, we have a number on the bottom. So now I can plug in 0 directly. The cosine of 0 is negative 1 over 6. Okay? So...
That's not bad, I like it.
No, I mean, I feel like nothing that we've done so far is like totally, oh my gosh, yeah. We'll get there, it will go over your head, but a lot of this is just basic
Up to
understanding.
this point, I think I could probably do the plan.
Right, I mean, you might make a couple mistakes, you might lose a couple points here and there, but it's not like any problem so far.
But then once you reach like the Lima contrastics,
What?
you might write
Yeah, it
this
looks like a
word.
peach. Looks like a peach.
No, it doesn't.
Okay, next one, limit as x approaches 0 from the positive side.
But without that.
Okay, hey, or negative side, sorry. Stay with me.
How can you, how does that affect it? Like, how do you know?
I'll tell you how that affects it.
Okay.
What you're doing in this case is you are plugging in a very, 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 very small, close to 0 negative number. Okay? So you have to think about this. If you take a very, very, very small, close to 0 negative number and raise it to the 1/3 power, in other words, you're taking the cube root of it. What are you going to get as an answer?
Very small.
A very small but still negative number, okay? Now, what is 2 over a very, very small negative number? Right, so what's happening here is this whole thing right there we can replace with negative 2.
I don't like that.
I thought you could take the like square root or cube root or something.
You can take the cube root of a negative number, but you can't take the square
So
root
it's just
of it.
1 plus infinity.
What's that?
So it's just as one.
Right, and then so 1 minus negative infinity is...
Just a little bit bigger.
Okay, And that's what it says in here, no work is necessary.
Oh.
Okay? Now, you get 1 point if you screwed up and made it negative infinity. And that's where from the negative side comes into play. Because if this was from the positive side, then you'd be plugging in a very, very small positive number. Which if you take the cube root of that, you get an even smaller but positive number. And 2 divided by that would be positive infinity. Okay? And then 1 minus positive infinity would give you negative infinity. So you would have flipped it, but you would have been close.
1 minus infinity would not be negative infinity.
1 minus infinity is negative infinity.
What?
1 minus 300 billion trillion is going to be basically
It's
negative
negative.
300
Or like 1 minus 2 is negative 1.
Ouch, Austin.
No, that's
That-
not real.
That just happened. Okay, so now we have a piecewise function.
Ooh.
I didn't think there was anything. No, this one though. Doesn't exist.
Doesn't exist.
That was a guess, but I couldn't figure it out. Mr. R. Wrong.
Oh, yeah, it does.
We got something to explain.
Okay, so this might be something where you would be a little bit wobbly on it.
Yep.
Okay? Piecewise function, and you want to take the limit as x approaches 3. Okay? This is something we talked about at the very beginning of the year, and we mostly did it by looking at graphs. And I would draw a graph like this, and it would be some crazy piecewise function, and there'd be a hole right there, there's a dot right there, and then there's something like this. Okay? And the questions that we talked about is if this is 1 right there, I would say to you, let's put this to be 2, and let's put this to be negative 1. I'm just trying to kind of reteach a little bit. Yeah, just review a little bit. If this was your graph, and I said to you, what is the limit as f of x approaches 1 from the negative side, you would say to me 2. Because here's 1, and on the negative side, the y value is 2. Okay? Then if I said to you, what's the limit of that function as x approaches 1 from the positive side, you would say to me, negative 1. Because on the positive side of 1, it approaches negative 1. And then I just threw something in there to confuse you. I would say, what is the value of the function at 1? And you go to where the dot is, and you say it's 1. Okay? But the key is, what is the limit as f of x approaches, as x approaches 1? It doesn't have one. Why? Because the left one and the right one are different. Okay, so what this question is really asking is, do these graphs meet at 3? Or does this one end up somewhere different than this? Okay, so all you have to do to figure this out is put in 3 to this function. So 1 plus the square root of 3 minus 3 over 3 is what? 1/3. So f of 3, kind of, if that's it, would be 1/3. If I plug in 3 into this, if I put in 3 right there, that'd be 3 pi over 2, right? 3 pi over 2 minus pi is pi over 2, so that's saying what is the sine of pi over 2? And you all know your little sine graph goes like this, so the sine of pi over 2 is 1. Okay? So the limit as this one approaches 3 from the negative side would be 1/3. This graph, the limit as it approaches 3 from the positive side would be 1. Since they're different, that means the limit doesn't exist. No, the math is really easy. That's what we have to understand what the problem is asking. Okay? If these came out to be the same, then the limit would exist, and the answer that we got would be the answer to it. Okay?
Next one, you're gonna get infinity over infinity, right?
Are you?
Or no, negative infinity. I don't know. Yeah, you'll get infinity over infinity if you put it in.
Did
Were you going to ask me something, Kyle, before we play this?
Will we ever get one of those ones with the 3 equations and they'll just ask us to find one side or
Positive side of the negative side, yeah, they might.
We'll see.
Okay, so this is one of those ones where we have, again, this is something that's not going to be hard, but you just might not remember it. Where we have a limit as x approaches negative infinity, and so you have to divide everything by the highest power of x that you have in the problem.
That's infinity.
Okay, square, because this limit is an
So
approach.
then,
So I'm gonna, so we'll let Brianna copy that. Okay, so if I divide everything by x, then this is 1 over x plus, and then this is that weird thing. If I'm dividing by x, but I'm doing it underneath the square root, what do I really need to divide by? X squared. So it's going to be 3 over x squared minus x over x squared.
This is not what I really do.
Okay, but change that.
Yeah.
Make it so that you can. What's the answer here? 0.
where'd you get the x?
Because if it's underneath the square root,
Oh.
x squared really is x in the sky. Okay?
Oh, I got this.
And it worked out also?
That's just x over x?
Yeah. Okay?
Wait, can you
The
do
highest
that?
power of x is just
We'll do that in a second. See if that works. Okay, so if I plug in negative infinity here to x, what is 1 over negative infinity?
Negative.
0. 1 over a huge
Yeah.
number, whether it's positive or negative, is going to be 0. Plus, what does this work out to be? 0. Minus, what does this work out to be? 0. Because
I don't like
infinity
clicking.
over this is going to cancel. This is reduces to 1 over x. And again, 1 over infinity, whether it's positive or negative, will also be 0. So that's 0 minus 0. And then like you said, the x is canceled, and that's just 1. Okay? All right, and so what do we have on the top? 0. And what do we have on the bottom? The answer is 0. Okay? Now, Cody, it's got to be Jack. Cody said we can also do the complex conjugate thing, so let's take a look at that and see if we like this better.
I understand that better.
Okay, so this, what was it, the square root of what?
3 minus x.
Over x. Okay, so you would then multiply top and bottom by,
1 minus.
okay? So first times first is 1.
Plus x.
Outside, no, because this was plus, so
Oh,
this
there
is
you go.
opposite. Outside and inside cancel, and then that's going to be minus 3 minus x over x times 1 minus, like that, okay? Negative 2 plus x over all of that stuff. Okay, now how do you get 0 out of that? Ah, there you go.
Because one's being added on top.
Right, one's being added and this one's being multiplied, so you just got lucky there that worked out. Okay? So this really wouldn't be any better than the other thing. You still have to divide by the highest power of x, and that's not going to do you much good.
So, this one's tough. This next one's real tough. The limicon trisectors. What?
Oh, okay, so now we're done with the limits, so
Yeah.
no limits. Okay, you guys get freaked out by those names. It doesn't mean anything.
Do you have to take derivatives?
Yeah, we're just going to end up doing some implicit differentiation.
Oh, yeah, the names are just what it's called, right?
Yeah. Find the coordinates of the point where the tangent lines at A and B intersect. Okay. So the key thing to this is, what do we know the coordinates of point A are?
0.
0 something. And we know that B is going to be 0 negative something. Okay? And so that's the point that we're going to use to find the slope for our tangent line.
Take the derivative.
You take the derivative.
Okay. 2.
2.
Everything.
Do everything.
Hang on.
Maybe.
Right. 2x minus 2 plus 2y times y prime. Plus 2x plus 2y Oh, the guys on one side.
Yeah, so that's.
Gang sides. I think we should distribute first.
You're right. 2x. Wait a minute.
So,
What?
You have to multiply those all out?
you know what?
How about we don't?
Okay. Like
How about we plug in these points first?
You want to do that?
Mm-hmm.
And then what?
Because I need to know the slope at that point, right? So that's going to tell me the slope at that point.
So,
So I'm plugging 0 for x and
And-
y for y.
0, 0,
Okay? Gone, gone, gone,
0.
gone.
Okay, hold on.
Poor Ed.
So,
How'd you get all those X's? Because you plugged in
Because I
0.
plugged in 0 for x.
Oh.
Because I want to know that essentially the slope at that point. You know, I plugged in y for y, right?
Right out.
okay,
So now
so,
you do.
So now it's a little bit nicer to work with. Can I be sneaky here? Will you let me be sneaky?
Show us
I'm gonna, I see that I've got a 2y squared times this stuff, and I've got a 2y times that stuff, so I'm gonna divide both sides by 2y first. Because that's gonna cancel those, that's gonna cancel that, and just leave that y. If you don't like that, you can do the distributing first and then solve. And you'll get the same answer.
wait, 2y squared divided by 2y, which is y.
Yep.
Why would it be,
Two cancel with one a lot.
why didn't you choose
The other 2y.
Why did I choose another 2y? This one right here? That's the same mistake you made in the last problem. Because that is negative 2
Oh.
plus 2y, so I can't cancel it.
Yeah.
Because it's being added, I can only cancel multiplication and division.
So then you distribute the y.
So now I'm going to distribute the y.
So negative 2y plus 2y squared 1
Let me say that again.
oh, negative 2y plus 2y squared y prime equals what?
Okay, so how do I solve that for y?
About that one.
No, I'm trying to
No.
solve for
Oh.
Add 2y first, and then you're gonna subtract.
Okay, so I'm going to get the y prime over here, and I'm going to get the minus 2y over there.
So I guess you could do that instead.
And I do. So all the y primes on the left, all the non-y primes on the right.
So divide by 2y squared. Uh-oh, but then you.
No, not divide by 2y squared, I have to factor out the y prime.
Oh, you.
Okay? What the heck does that tell us?
This is y prime.
Mm-hmm.
This tells us y prime is meaning the coordinates.
Wow, that's a slope if for,
Yeah, but we still have this y in there, which is gross, right? Okay, so you can so keep that in mind.
Yeah.
Okay, we need to go back and fix this a little bit.
Mr. Aldrich, you were texting Jack.
Who would you be texting right now?
My mom.
Can you pick this up?
what's the M I use for it?
What's the what?
Microphone?
I can bring this shit out.
Sixteen.
So what? Oh, it is. Menu. Cancel. What is that?
What are you trying to do with it?
Okay, so we don't want an equation for a line that has that in it, right?
Right.
I mean,
Why?
yeah, too many y's. So we need to figure out what y equals in from the original problem when x equals 2.
Okay.
So can we just plug it in and solve for y?
Just plug 0 in?
For the original one.
I guess.
So these cancel, those cancel, and that cancels, right? So that's pretty simple. So that means y to the fourth equals y squared. is true in a couple of very specific cases.
Oh, like what?
0 would be one of them, and that's why if you look at the graph, it also does have a y-intercept at 0. Okay, but that's not the ones we're concerned about. What is
Y equals one, negative
y equals 1 or y
Negative
equals negative 1. So we just needed to get a little more specific about these points here, and that would have helped us out a lot back here. Because instead of just plugging in 0 and solving for y prime, we should have been plugging in 0 and 1 and solving for y prime. Sorry, I made the algebra more complicated than it needed to be. But still okay. So we're going to plug in 1 there, and what do you get?
What is, look at what is it?
We're going to do
You
both.
get 2.
You get what?
2.
2 over 1, which is 2. Okay? And she says, why didn't we plug in negative 1? Well, we're going to plug in negative 1 also. And that would give me negative 2 over 1, which is negative 2. Okay? So now you can come up with the equation for the line through A. Because we know the coordinates of that point are 0, 1, correct? And we know the slope is 1.
How come we don't plug in 0 at the very beginning?
How come we didn't? How come we did?
How come we didn't?
How do you know the
We
slope?
did.
Why is the
She's
slope
talking about
one?
the plug-in to the original equation we just did,
Yeah.
because we weren't thinking about it.
Why didn't we do
Yeah,
that to
no,
start
see
with?
where the yellow portion is? I'm like,
Uh-huh.
why didn't we do that at the very beginning?
Because we didn't think about it.
Okay, I'm just wondering.
Right, that's what we should have done. We should have looked at the graph and said, okay, point A obviously has an x coordinate of 0. So to find out what its y coordinate is, plug 0 into the original function and solve for y.
Yeah.
And then we would have had these 2 points to start with. And then when we took the derivative, instead of solving it all for y prime by plugging, we should have plugged in 0 and 1 and solved it.
No, we did it right, we just did it.
Yeah, we ended up with the right answer, we just took a little bit more
Okay,
work.
wait, why are you saying the slope is 1?
It's 2.
Oh, it's 2.
It's 2.
Sorry. Okay, so the equation for the tangent line that goes through point A is y minus 1 equals 2 times x minus 0, right? Or y equals 2x plus 1. And the equation of the line that goes through point B
Wow, we're not even done yet.
is, nope, we're not. That has 0, negative 1, right? And a slope of negative 2. So that's going to be y plus 1 equals negative 2 times x minus 0. So y equals negative 2x minus 1.
Now
What
how do we
is the-
find it where they intersect?
How do you find where they intersect? Set them equal to each other.
And then you solve for x.
We're going to need to solve for x and for y. So I have 2 equations, y equals 2x plus 1.
How'd you put slope as 2 when it was, what's it called, when it's 2y over 2y squared?
We plugged in 1 for y,
Oh.
like you wanted to do before, negative 2x minus 1. Okay, so I set those equal to each other.
How are you also going to solve for y?
Well, once you get the x, you plug it in. Right? So 2x plus 1 equals negative 2x minus 1. So if I add 2x to both sides, we get 4x equals negative 2. So x equals negative 1/2.
Yeah.
And if I plug that into either one, and you should plug it into both to check to make sure that your answer is correct, you should get the same answer either time, which is that y equals, nope, nope,
You plug it into where?
How is
either this
Oh,
or
yeah.
this, you should get the same answer either way.
2,
No,
Okay, wait, just give me a second.
I'm giving you a second.
0.
0.
Oh, okay, I did.
So the
Good
place,
job, Cody, you redeemed yourself.
so the place where those 2 lines intersect is at negative 1/2.
That was a lot of work.
That was a ton of work, but we made it more work than it needed.
That we did.
Okay?
Hooray!
All right, I feel good about stopping there. I know we have a bit of time left, but, yeah, that last one was a humdinger. So